All right, let's dive in. Today, we're going on a hunt for a cosmic ghost, a mysterious substance that makes up most of our universe, but somehow remains completely invisible. We're going to try and unmask dark matter.
Okay, I'm going to start with just one number, 95%. That's how much of the entire universe is made of things we literally can't see or touch. A big chunk of that is something called dark energy, but a huge piece of the pie is our suspect for today, dark matter.
Seriously, just let that sink in for a second. Every single star, every planet, every galaxy we have ever observed, all of it amounts to a measly 5% of what's really out there. The rest is just missing. And that is the cosmic crime scene that astronomers have been staring at for nearly a century.
So where do you even begin with a mystery this big? Well, like any good detective story, it starts with the first few clues, going all the way back to the first astronomers who realized something was profoundly wrong with the cosmos.
You know, the crazy thing is, this idea of dark bodies hiding in space isn't actually new. Way back in 1884, Lord Kelvin had a hunch that there were stars we just couldn't see. He had no idea how right he was, or the incredible scale of the mystery he was hinting at. The first real bombshell, though, that came in the 1930s thanks to a Swiss astrophysicist named Fritz Zwicky. He was looking at this cluster of galaxies and he realized they were buzzing around like angry bees, way too fast. For the cluster to hold itself together and not just fly apart, he calculated it needed something like 400 times more mass than he could see. He gave it a name, Dunkel Materie, or as we know it, dark matter. Now, Zwicky's idea, well, it was mostly ignored for decades. Classic, right? But then, the evidence it started piling up. See, even though we can't see dark matter directly, it has left its gravitational fingerprints all over the universe. And the case was absolutely blown wide open in the 1970s because of the incredible work of astronomer Vera Rubin. She was studying how spiral galaxies spin, and what she found was it was undeniable proof that something massive and invisible was pulling the strings. Okay, so this right here, this is the smoking gun. If you only count the stars and gas you can see, gravity says the stars way out on the edge of a galaxy should be moving much, much slower than the ones near the center. Just like Pluto moves slower than Mercury in our solar system. But they aren't. They're all moving at almost the same incredible speed. The only way this makes any sense is if the entire galaxy is sitting inside a giant, invisible halo of dark matter. And look, it doesn't stop with spinning galaxies. Not by a long shot. We can literally see its gravity bending the light from distant objects. We've even caught it red-handed in cosmic collisions, where it's separated from normal matter. Its influence is even printed on the afterglow of the Big Bang itself. The main takeaway here is that all of these totally independent lines of evidence point to the exact same invisible culprit.
So, okay, the evidence is it's overwhelming. Something massive is definitely out there. So let's do what detectives do. Let's build a profile of our invisible suspect based on all these clues.
And this cosmic pie chart really puts our ignorance on full display, doesn't it? All the stuff we're made of, what we call ordinary matter, is just a tiny sliver. And while dark energy makes up most of the universe's energy, dark matter completely dominates its mass. It makes up 85% of all the matter out there. It really is the invisible scaffolding of our entire universe.
So what is this stuff exactly? Well, by definition, dark matter is a substance that doesn't interact with light at all. It doesn't absorb it, it doesn't reflect it, it doesn't emit it. It's not dark like a black hole is dark, it's completely transparent. It just sails right through you and me and everything else, only making its presence known through its gravity.
Our best models also tell us it's cold. Now, that has nothing to do with temperature. It's all about speed. It means it moves slowly, and that's absolutely crucial, because slow-moving particles can clump together really easily under gravity. So in the early universe, these clumps of dark matter acted like little gravitational seeds, pulling in gas and dust to form the very first stars and galaxies.
All right, so we've got the evidence, we've got a profile, but to really solve the case, you have to catch the culprit, right? So, how in the world are we trying to find this cosmic ghost?
Well, scientists are basically casting this huge, wide net, trying three main strategies at once. There's what we call direct detection, where we build these hypersensitive detectors deep underground, basically just waiting for a single dark matter particle to bump into one of our atoms. Then there's indirect detection, where we're looking for the aftermath, like a burst of gamma rays,
when two dark matter particles might smash into each other out in space. And finally, we just try to make the stuff ourselves, smashing particles together at insane speeds at places like the Large Hadron Collider.
So who's in the lineup? Who are the prime suspects? For decades, the leading candidate was something called the WIMP, a weakly interacting massive particle. They fit the theory so perfectly it was called the WIMP miracle. But after years and years of searching, the trail has gone cold. That shifted a lot of focus to other candidates, like these incredibly light particles called axions. And there's even a wilder idea gaining steam, that dark matter is actually made of ancient, tiny black holes forged in the Big Bang itself.
And this is a huge deal. The fact that we haven't found WIMPs, it's a really big plot twist in this story. Our detectors have gotten so sensitive that they're starting to get blinded by background noise from other little ghost particles called neutrinos. Hitting this wall without any discovery has forced scientists to totally rethink everything and get a lot more creative.
Which, it brings us to the real heart of the matter. This isn't just some academic puzzle for physicists to argue about. The hunt for dark matter is genuinely one of the most important quests in all of science.
Because the answer, whatever it turns out to be, won't just be a new particle to add to the textbooks. No way. It will tell us about the birth of our universe, the ultimate fate of all galaxies, and the fundamental laws that govern reality itself. It's the key to completing our picture of the cosmos.
So I'll leave you with this final kind of mind-bending thought. We've been hunting for one culprit, right? One single ghost particle. But what if the dark world is just as rich and complex as our own? What if there's a whole family of dark particles out there with their own strange forces? We've spent a century trying to understand just 5% of the universe. Imagine what we'll learn when we finally turn the lights on for the other 95.